Hi everyone, and you are welcome to this lecture, Generators in Python. In this lecture, I'm going to define what a generator is, then we will see how we can create a generator, so we will learn about generator syntax, generator expression syntax, generator function syntax. After that, I will compare between generator function and the regular function, and I will end up this lecture by a quick summary. So let's get started. Let's start by defining what a generator is. Generator is a simple and memory-efficient way to create an iterator. In a previous lecture, I have defined what an iterator is, and as I mentioned that, the iterator is an object that respects the iteration protocol, in which the object saves its current state, and whenever we use next function with the iterator, we get the next item and the object updates its current state. Now, why generator memory efficient? Because generators compute the value only when you ask for it, and this is known as lazy evaluation. To understand why generator is important, let me give you a simple example. Assume you have a large text file and you want to count how many the word hello occurs in this file. The size of the file, let me say 32 GB, but you have RAM only 16 GB. In this case, you are not able to load the complete file in your RAM memory. So what is the solution in this case? The solution is generator. Because generator will help you to write a code which is able to read the file one line at a time. You can process this line, count how many hello words you have in this line, and then throw this line away and get the next line. And as you see here, I'm able to process a very large file using very small amount of memory. And why we are able to do that? Because we are using generators. Now, to create generator, you have to know that we are able to create generators in two ways. The first one using generator expression, the second one using generator functions. Let's see the first way. Actually, there are three syntax you have to be familiar with in order to define a generator. We have expression for element in iterable, we have expression for element in iterable if a condition, and we have expression if condition else expression for element in iterable. A very important note here that if you want to use if alone, it comes after for. If you want to use if else, it comes before for. And as you see here, the syntax of generator is exactly the syntax of comprehensions that we have learned about in a previous lecture. But here, you have to be careful that here we use parentheses instead of square bracket or curly braces. So parentheses to create generator expression. Now let's move to PyCharm IDE to see some code examples about this syntax. First of all, let's see an example about the first type of syntax. Assume I have the following list, which is numbers 1, 2, 3 until 6. And the first type of syntax, as we know, we have expression for element in iterable. And I want to create a generator expression, which will give me n to the power of 2 for each n in the list numbers. So I will say gen equal to parentheses expression n to the power of 2 for each n inside numbers. Now let me print gen. Run. As you see here, I have a generator object and there is no number has been generated. And this is what it has been explained exactly. So generator will help me to define expression, but until now, there is no value has been generated. Only the expression has been defined. And look here, in this expression, in this generator, I have expression and then iterable, which is numbers. Now the question is how to extract the value from the generator. Because generator is an iterator, it's so simple. We have two ways to extract the values. I can use a for loop, so I will say for a in generator, print a, and run. As you see here, I got 9, 16, 25, 36, and so on. And here you have to keep in your mind that when I say for a in generator, each iteration, one item is generated and then it's printed. Not all items together have been generated. And why this is important? Because this is the main purpose of generator, is to keep memory free as much as possible. So each time we have only one item. The second way to extract items is by using next function. So I will say next generator and I will assign the value inside item. And don't forget that I'm able to use next because it's an iterator, item. And here I will take this 3 times, for example, and run. As you see here, the first value is 1, first next, then 4, second next, then 9, which is the third next. And don't forget that if you use next function more than 6 times in this example, because I have 6 elements, I will get stop iteration error. This error because the generator has been exhausted and there is no more item to be generated. Now let's see another example about the second type of syntax of generators. I will remove all of this and I will print this. The syntax is expression for element in iterable if condition. Let me say that I want to generate n to the power of 2 for each n inside the list numbers only for the elements which are bigger than 2. To express this, I will use parentheses because now I'm defining a generator. Then I will say n to the power of 2, which is my expression, for n in numbers, which is the iterable that I want to use its items, and then I will say the condition n bigger than 2. To extract the item, I will use for loop as you see here. So print item. Also, I will print gen2 to show you what I will get. Run. So the first thing is printed is generator object, and as you see there is no values have been generated till now, but the values have been extracted using for loop. So I have 9, 16, 25, 36, and 1 and 2 did not appear in the result here because I restrict the elements to be bigger than 2. Now let's see one more example about the third type of syntax of generator. So in this syntax, we say expression, then we use if condition with 2 expression for each element. In this syntax, we use expression, then if condition with else, and then for loop. If becomes first when we have if else in the syntax. Now let me say that I want to do the following. I want to extract n to the power of 2 if n is bigger than 2. Let me say that I want to generate n to the power of 2 if n is larger than 2. Else, I want n divided by 2 for each n in the list numbers. How we can represent this in a generator expression? It's very easy. So I will say it's n to the power of 2. So I want to generate this value if n is bigger than 2. Else, I want to generate n divided by 2 and I want to take the items from the iterable numbers, which is a list in this case. Let me print gen3. And let me print the items, and I will say for item in gen3 print item, and I will run. As you see here, the first thing was printed is generator object, so there is no values have been generated yet. And here I got the items 0.5, 1.0. Why? Because 1 and 2 are not bigger than 2, so I will take n divided by 2, and the result in this case 0.5 and 1. But when n is bigger than 2, like 3, 4, 5, 6, I got n to the power of 2, which will give me 9, 16, 25, and 36. And that's all about generator expression. Now let's talk about generator function syntax. It's the following. As you see, generator function, it's very similar to traditional function, in which I use def keyword to define the generator, then I put the generator name, then list of parameters, one statement or multiple statements, I use indentation at the beginning, then I use yield statement. And this is the main difference in the syntax between traditional function and generator function. As you see here, I use yield keyword to return a value from generator function. Now let's move to PyCharm IDE to understand more about generator functions. The first example that I want to share with you is the following. Assume I have a generator function, it's named genFunction1. Inside this function, I will define a variable n equal to 1, and then I will say yield n. First of all, I will call this generator. So I will say gen equal to generator function 1. Then I will print gen, and I will run. As you see here, I got generator object. I didn't get the value n, which is 1 in this case. Why this happened? Because as I mentioned before, this is a generator object, which means you will not generate any value until you use for loop or next function. So if you want to generate the value, you have to use next, as you see here. And when I run, directly you will say that I got 1. Now, if I comment this print statement and I say print again, and I print my generator, look, if I replace yield by return, so now it becomes a normal function, and if I run, I will get 1. So from this we can understand that when we call a function, we get the result directly. When we call a generator function, we get a generator object and the function will not be executed yet. The result will be taken using next function. Now let me show you another example. I will assume that I have a generator function, it's named genFunction2, and then I will say n equal to 1 yield n equal to n plus 1 yield n, and n equal to n plus 1 yield n. Let's see what I will get when I print next, and let me assign the generator into a variable gen, and then print next. Run. As you see here, I got 1. Let me print next generator one more time, and run. As you see here, for the first time, I got 1. For the second time, I got 2. And for the third time, I got 3. So we can understand that when we use next function, there is something happen to make the generator remember where was the last yield statement that has been executed and give me the value of n. So when I use next function for the first time, the first yield has been executed and the value of n has been stored somewhere and the value of 1 has been kept. After that, when I use next function in the second time, the original value of n, it's 1, 1 plus 1 is 2, is assigned again to n, and then the value of n has been returned. And when I use next for the third time, the same thing happened exactly. So we can conclude from that the internal state of the generator function is stored until the generator has been exhausted, which means until we extract all the possible items from this generator. Now let's see a more practical example about generator function. Let me say that I want to define a generator function which is able to generate all the even number from number 1 until number you specify by yourself. In this case, I will define a function and I will call it range2 because range is a keyword and it takes one parameter which is n, and within the function I will say for k in range n yield if k modulus 2 equal to 0 because I want to return only the even number, I will say yield k. Now let's use my generator in a concrete example. So let me say for k in range 2, for example, until 10, print k. So in this program, I want to generate all the numbers from 1 until 10, and those numbers should be even numbers. Run. As you see here, I got 0, 2, 4, 6, 8. Keep in your mind that in each iteration, one number is generated and the value of this number is returned. Not all of these numbers have been generated together. Now let me compare between a generator function and a regular function in a more detailed way. First of all, in generator function, we use yield to return a value, whereas regular function uses return to return a value. Generator function, when it's called, it returns an object, which is an iterator, but does not start execution immediately, whereas when we call the function, it starts execution immediately. In generator function, once the function yields, the function is paused and the control is transferred to the caller again. Whereas when a normal function returns, the function is terminated and the control is transferred to the caller and nothing about the state will be saved. However, when a function returns its value, the function is terminated and the control is transferred to the caller. So in this case, it's paused. In this case, it's terminated. The last point is, generator function save the local variable and their states between successive calls, whereas in the case of regular function, all local variable and the states are not remembered between successive calls. So each time regular function is called, will start from a clean memory. And that's all about the comparison between generator function and regular function. Now let's summarize what we have learned in this lecture. First of all, generator has been defined as a simple and memory efficient way to create an iterator. And we say that generators are memory efficient because they use the concept of lazy evaluation, which means generating the value only when we need this value, so we don't need a huge amount of memory to keep the values. In order to create a generator, we have two ways. We can define a generator using generator expressions or generators functions. In generator function, the main keyword is yield. And when we use yield within a function, directly it will be converted into a generator function. Now please refer to the file Generators in Python Challenges, in which you will find some challenges to practice what you have learned in this lecture. That's all for this lecture. Thank you very much for your time, and if you are available, join me in the next lecture.